Okay, in this question, that the gas cylinder is being heated from 20 degrees Celsius to 100 degrees Celsius, and in the process the piston moves out and it stops moving when the temperature is steady. So now the question here is to make a comparison between the average distance between the gas molecules. Okay, let's look at the first part. What happened to the average distance between the gas molecules? We have to look at the volume. If just now we say because it stopped moving, meaning actually it was from a smaller volume then increased to a larger volume. So we say that because there is an increase in volume, therefore the average distance between the gas molecules will be greater. So we just choose greater. Alright, so the pressure, next, the pressure of the gas after the piston stops. So even at 100 degrees Celsius, and we look, the volume increases and also it stops moving. Okay, this part is tricky because many students may be mistaken that at 100 degrees Celsius, therefore pressure must be larger. However, because volume has increased, so you can't tell. How to tell what is the pressure? Will the pressure be greater, still remain the same, or less than the original or before? Okay, let's look at the equilibrium. Because let's say in a cylinder, in a gas cylinder, here like this. Okay, there's gas pressure on the cylinder from the inside, and also there's the gas pressure or air pressure, atmospheric pressure from the outside. So when the piston stop moving, that means it is in equilibrium, in pressure equilibrium. Therefore, the pressure inside the gas cylinder and the pressure outside is the same. So if pressure outside is P0, inside will be P0. Okay, let's look at the beginning at 20 degrees C. In 20 degrees C, nothing happened. There's the pressure, they say at 20 degrees C, the pressure should be the same as the atmospheric pressure. So we can deduce that actually the the pressure in the cylinder remain the same when the piston stop moving. Okay. Next, the average speed of the gas molecule. Okay, when we are looking at the speed of the gas molecule, we should look at the kinetic energy. Okay, kinetic energy is related to the temperature. Since the temperature has increased from 20 to 100 degrees C, then the speed is greater. Okay, we put a note here because temperature increases. Alright, and now the last one, the frequency of the collisions between the gas molecule and the piston. Alright, when you look at the frequency of the collision, the only one thing that we want to look at is actually is it affected by pressure. So we have to refer back to here. Okay, if we get the number 2 item correct, or say that the pressure remain the same, then we should say also deduce that actually frequency of the collisions between gas molecule and the piston should remain the same because there's no change in pressure. So these two questions, the number 2 item and the number 4 item, they are related. So because I'm going to put it, the pressure remain the same. Pressure unchanged. That's the reason.